This is Nafyunisha, Assistant Professor, Department of Mathematics, Jamal Muhammad College. In this video, I explain some basic concepts in number theory. In first part, I give some introduction about number theory. In second part, I'll explain some basic concepts in number theory. Finally, I explain fundamental theorem of arithmetic. Number theory is a branch of pure mathematics devoted to the study of the natural numbers and the integers. It is the study of the set of positive whole numbers, which are usually called the set of natural numbers, as it holds the foundational place in the discipline. Number theory is also called the queen of mathematics. Number theory is partially experimental and partially theoretical. The main goal of number theory is to discover interesting and unexpected relationships between different sorts of numbers and to prove that these relationships are true. Results from number theory have countless applications in mathematics as well as in practical applications including security, memory management, authentication, coding theory, etc. The most important application of number theory is that it is the key foundation of cryptography. Our strong encryption algorithms and systems have developed because of the impetus provided by number theory. For example, your data cannot be easily accessed by anyone because of the strong encryption system. Classification of numbers. There are different types or families of numbers. Without numbers, we can't do counting of things, date, time, money, etc. Sometimes these numbers are used for measurement and sometimes they are used for labeling. Number theory is the study of the set of positive whole numbers, which are often called the set of natural numbers. Since ancient times, people have separated the natural numbers into a variety of different types. Real numbers, complex numbers, rational, irrational, integer, whole numbers, natural numbers, odd and even numbers, square and cubic numbers, prime and composite numbers, triangular number, perfect number, Fibonacci numbers. So many of these types of numbers are undoubtedly already known to you. The next basic definition is set. The collection of well-defined distinct object is known as a set. The word well-defined refers to a specific property which makes it easy to identify whether the given object belongs to the set or not. These are all different types of sets in basic set theory. Next definition. Function. A function is a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. The input value make up the domain and the output value make up the range. The types of functions can be broadly classified into four types based on element: one-to-one, many-to-one, on-to, one-to-one and on-to function, into function, etc. Here one-to-one and many-to-one form a function, but one-to-many, many-to-many is non-function. In second part, I explain some basic concepts of number theory. First one, principle of mathematical induction, and second one, well-ordering principle, and last one, pigeonhole principle. Mathematical induction is a mathematical technique which is used to prove a statement, a formula, or a theorem is true for every natural number. This method is a form of deductive reasoning. Mathematical induction is used to prove that a statement P of n holds for every natural number n equal to 0, 1, 2, 3, etc. That is, the overall statement is a sequence of infinitely many cases. A proof by induction consists of two cases. The first, the base case, proves the statement for n equal to 0 without assuming any knowledge of other cases. The second case, the induction step, proves that if the statement holds for any given case n equal to k, then it must also hold for the next case n equal to k plus 1. These are all the typical example of mathematical induction. Next definition, well-ordering principle. Every non-empty set of non-negative integers has a smallest element. This statement is known as well-ordering principle. For example, set of all natural numbers and whole numbers are well-ordered set. If the set is non-empty and non-negative, then we can find the least one. Suppose we take the set of -1 to -infinity. In this set, we can't find the least element. 1. The pigeonhole principle. The pigeonhole principle states that if n items are put into m containers with n greater than m, then at least one container must contain more than one item. Pigeonhole principle is one of the simplest but most useful ideas in mathematics. A common way to illustrate this principle is by assuming that k plus 1 pigeons fly to k pigeonholes. Then there must be at least one pigeonhole containing at least two pigeons. This is a trivial observation which, however, can be used to prove many results. If 3 pigeon occupies 2 holes, then there must be one of the hole with at least 2 pigeons. A function from one finite set to a smaller finite set cannot be one-to-one. There must be at least two elements in the domain that have the same image in the codomain. I hope this is useful for you. Thank you.